Welcome to this hands-on tutorial on Amazon ECS. Let's start with the basics. Amazon ECS stands for Elastic Container Service. It's a managed container orchestration service. This means AWS helps you run, manage and scale containers without setting up your own servers. You don't have to install Docker Swarm Kubernetes or any cluster management software yourself. AWS does it for you behind the scenes. Now, what is an ECS cluster? An ECS cluster is simply a logical group where your containers run. Think of it like a playground or workspace. Inside this cluster you can run multiple applications, services, and tasks, all isolated but managed together. Now, how does it work? First, you create an ECS cluster. Then you define your application by packaging it into a container image just like you would with Docker. You register that image into ECS using a task definition. It's like a recipe for running containers. Finally, ECS takes care of starting, stopping, scaling, and managing the containers for you. You choose where the containers run. ECS gives you two main choices. Fargate, serverless. You don't manage servers. Just run containers. EC2 instances, you bring your own servers to run containers. Now let's connect it to Docker. If you know Docker, think of ECS like this. In Docker you build images and run containers manually. In ECS, you still build Docker images. But AWS runs and manages the containers for you automatically. ECS uses Docker under the hood to launch your containers. In simple terms, Docker equals run containers manually on your machine. ECS equals run and manage containers automatically across cloud servers. Now, some real-world use cases for ECS. Running websites and back-end services inside containers. Microservices architectures. Batch jobs and background processing. Event-driven applications. Scalable APIs without managing servers. ECS helps you focus on building applications, not on server management. And because it's tightly integrated with AWS services like CloudWatch, IAM, and ALB, it's easy to monitor, secure, and scale. In short, ECS is a simple yet powerful way to run Docker containers in the cloud with less overhead. With this introduction, let's dive into the hands-on practice with ECS. Go to the ECS console. As you can see, Amazon ECS is a highly scalable and fast container management service. It makes it easy to run, stop, and manage containers across a cluster. First, let's quickly talk about pricing. Amazon Fargate is not included in the AWS free tier. You will be charged based on the vCPU and memory resources you use. If you want to avoid charges, you can still follow along carefully. Amazon ECS on Amazon EC2 is included in the AWS free tier, but only if the EC2 instances you use stay within the free tier limits. Amazon ECS Anywhere also offers a free tier. This allows you to explore and test running containers on your own infrastructure without immediate costs. We'll start by doing hands-on practice with Amazon ECS tasks, and then move on to working with ECS services. This approach will help you build a stronger understanding of how ECS works. First, we'll create 3 simple tasks: a web server, a database, and a Java batch job, all running on Amazon Fargate. And then we'll set up an ECS service using Amazon ECS with Amazon Fargate. Let's begin with the Apache web server task. First, start by setting up our ECS cluster. Click on Clusters. Then click Create Cluster. Give your cluster a name, like Demo Cluster. You'll see 3 infrastructure options. AWS Fargate, a serverless option where AWS runs containers for you. Amazon EC2, you manage your own EC2 instances to run containers. External instances with ECS Anywhere, you can register external servers after cluster creation. For this demo, choose AWS Fargate. Click Create. Once your cluster is ready, let's move on to creating the Apache web server task. Now the cluster has been created. Go to Task Definitions. Click Create New Task Definition. Name it Apache Web Server Task. Choose Fargate as the launch type. The default vCPU setting is fine. Set the memory to 2 GB. Now, add a container. Set the container name to Apache Container. Use the image HTTPD, latest. Expose port 80 to allow web traffic. Leave the rest of the settings as default. Click Create to save your task definition. Now, go back to your cluster. Inside the cluster, click on the Tasks tab. Then click Run New Task. Choose the Apache Web Server task you just created. For networking, the default VPC and subnets are fine. Create a new security group and allow port 80 from anywhere. Make sure to enable auto-assign public IP so your task can be accessed from the internet. Click Create. Wait for the task status to change to running. Now the task status has changed to running. Once running, find the public IP address under the task's network section. Open that IP address in your browser. You should see the Apache HTTP server home page. It works. Congratulations! You've successfully deployed your first ECS task using AWS Fargate. Finally, let's clean up. Go to the cluster and stop the task. Now, let's set up the database task. Create a new task definition. Name it MySQL-DB task. Use AWS Fargate as launch type. To run this ECS task, we will use the existing ECS cluster that we created earlier. The default CPU is OK. And memory configuration is OK. Add a container named MySQL container. Use the image MySQL 8. Expose port 3306. Add environment variables for MySQL database and MySQL root password. Click Create to create this ECS task definition. Now, run the task in the demo cluster. Create a new security group to allow inbound traffic on port 3306 for database connections. Make sure that the public IP is enabled. Click Create to create the task definition. Wait until the task is running. Now the task has started running. Find the public IP. Now let's test this MySQL instance. Use a MySQL client to connect. Enter the MySQL root password that you configured in the environment variable. We are now connected to the MySQL database instance running inside the ECS container. You have now deployed a MySQL database inside ECS. Now, let's stop the ECS task. Go to your cluster and click on the Tasks tab. Select the ECS task you want to stop. Click on Stop Task and confirm. Wait for the task to fully stop. Once done, you'll see that the task has been successfully stopped. Finally, let's deploy a Java batch job task. First, prepare a simple Java app that prints a message and exits. In this demonstration, we have a simple Java program called app.java. This class contains a main method, which serves as the entry point for the application. When the program runs, it prints a message to the console saying, "Starting Java batch job on ECS." Then, it simulates some batch processing by pausing, or sleeping, for 10 seconds. After the pause, it prints another message. "Completed Java batch job." This program is designed purely as a demo to show how a Java batch job could run inside an ECS task. It doesn't perform any actual business logic, it's just a basic placeholder to demonstrate task execution. Build a Docker image for your Java app. In this Docker file, we are creating a simple Java application container. We start with the base image OpenJDK 17, which provides the Java Development Kit version 17. Next, we copy the app Java file from our local machine into the container's file system. After that, we compile the Java file inside the container. This generates class file. Then, we define the default command for the container to run, which starts the compiled Java application. This setup builds a container that compiles and runs a simple Java program. In this script, we are preparing and uploading a Docker image to Amazon ECR. First, we build the Docker image locally. This creates an image named Java batch job from the Docker file in the current directory. Next, we create a repository in Amazon Elastic Container Registry, or ECR. After creating the repository, we tag our local Docker image so it matches the ECR repository address. Now, before pushing the image, we need to authenticate Docker with ECR. Finally, we push the Docker image to ECR. This completes the process of building, tagging, authenticating, and pushing our Java batch job Docker image to AWS ECR. Let's run the shell script to push the Docker image to ECR. The script is now running. As you can see, the image is being successfully pushed to the ECR repository. Now, we can use this image to run our ECS task. Now, in ECS, create a new task definition. Use the custom Java image from ECR. No ports are needed for this batch job. Click Create to create the task definition. Run the task manually inside the demo cluster. For this demo job, one subnet is enough. Pick an existing security group. Keep the rest of the settings as they are, and click Create. Now, let's wait for the job to move to the running state. It's running now, so let's take a look at the logs. You'll see that it logged the initial message, then the thread goes to sleep for 10 seconds. After that, it logs the completion message. Now, let's clean up. Stop the ECS task and delete the ECS cluster. Congratulations! You have now practiced 3 types of ECS tasks: an Apache web server, a database, and a Java batch job. Click on Create Cluster. Let's name the cluster ECS Demo Cluster. We'll leave the default namespace as it is. Now, for infrastructure options, we have 3 choices. AWS Fargate, serverless containers. AWS runs them for us without us managing servers. Amazon EC2 instances, we bring our own EC2 instances to run containers. External instances using ECS Anywhere, we can run ECS containers in our own data centers. For this demo, we'll enable AWS Fargate and Amazon EC2 instances. Next, we set up an auto-scaling group for EC2. Choose the operating system. I'll pick Amazon Linux 2. For instance type, we'll use T2 Micro, free tier eligible. Set desired capacity, minimum 0 and maximum 6 instances. No SSH key pair needed, so we'll skip it. We'll leave the root EBS volume size as default. Now, let's configure the network. Select the default VPC and let's use all available subnets. For the security group, create a new security group to allow incoming traffic on port 80. Set auto-assign public IP to use subnet settings. We are not changing monitoring or tags. Now, click Create to create the cluster. While the cluster is creating, let's check the auto-scaling group. On the left-hand side, click Auto-scaling groups. You'll see a auto-scaling group. It has desired capacity 0, min 0, and max 6. This scaling group was created automatically for our ECS cluster. Notice it's spread across availability zones, giving high availability. Now, let's wait for the cluster creation to complete. Once created, click into ECS Demo Cluster to explore. You'll see 0 services and 0 tasks, because nothing is running yet. Now, go to the Infrastructure tab. Here, you'll find 3 capacity providers. Fargate, to run tasks serverlessly. Fargate_Spot, to run tasks at lower cost using spot capacity. ASG provider, to run tasks on EC2 instances using auto-scaling group. Currently there is no container instance because there is 0 instance in the auto-scaling group. Let's scale it up. Go to ASG. And click on Edit. Set the desired capacity to 1. This will create an EC2 instance. The instance will automatically register itself into the ECS demo cluster. Now, wait a few minutes for the instance to become in service. Once ready, refresh the ECS console. You will see the EC2 instance under Container Instances. The instance shows available CPU and memory. We can now run ECS tasks either on Fargate, Fargate Spot, or on this EC2 container instance. Our ECS cluster setup is complete. Now we are ready to launch tasks and services in the cluster. Let's start by creating a new task definition. Open the Task Definitions panel and click Create New Task Definition. Give it a name. I'll call it Apache Web Server Task. For infrastructure, we'll choose AWS Fargate, a serverless compute option. Operating system is set to Linux by default, which is good. Now choose the task size. We'll keep the default setting of vCPU. Memory is fine too, we will keep it simple. You can change them if you would like. For task role, a task IAM role allows containers in the task to make API requests to AWS services. We'll skip assigning one, since we're not making requests to AWS services inside the container. For task execution role, keep the default, ECS will create one if needed. Let's provide container name, Apache container. For the container image URI, we'll use HTTPD image from the Docker Hub. Since we're using web server image, we need to map port 80 on the container. Port mapping of 80 is fine. We'll leave all other settings, environment variables, logging, storage, as default. By default, AWS Fargate provide ephemeral storage. Click Create. Our task definition is now ready. Now, let's deploy this task definition as a service. Go to Clusters. Select your cluster. Under Services tab, click Create. Select the task definition. Task definition revision, you will see one. In my case, I have deployed this task definition earlier, that's why it is not showing revision as 1. Set the launch type to Fargate and platform version to latest. Deployment configuration. Keep the service type as replica and set the number of tasks to 1. Deployment options and deployment failure detection can be left as default. Now configure networking. Default VPC is fine and available subnets are fine. Create a new security group. Allow HTTP traffic on port 80 from anywhere. Enable auto-assign public IP. Next, attach a load balancer. Create a new application load balancer called DemoALB for ECS. Set the container to listen on port 80 with HTTP protocol. Create a target group named TG Apache Web Server. Rest all defaults are okay. Now review the settings, everything looks good. Click Create to create service. Wait for the service deployment to complete. Once done, go back to the service view. You'll see one desired task, one running task, and status active. Now, check the load balancer. Copy the DNS name, open it in a browser, and you should see the Apache Web Server home page, which displays, it works. Success. Now let's see how scaling works. Update the service to set the desired tasks to 3. Click Update. ECS will automatically launch 2 more tasks on Fargate. After a minute, refresh the page, you'll see all 3 tasks running. When refreshing the browser, the load balancer distributes traffic across all tasks. Finally, let's scale down. Update the service again, setting desired tasks to 0. This stops all running containers but keeps the service configuration. Now check the target group. No active targets are registered. Both the instances are draining out. Let's delete the resources. Delete the ECS service. Delete the auto-scaling group. Delete the ECS cluster. And that's it. You've seen how to create a task definition, deploy a service using Fargate, configure networking and load balancing, and scale your application up and down easily. Let's talk about running an ECS task directly versus running it through an ECS service. When you run a task manually, the task runs once. After it finishes, or if it crashes, it stops. There's no automatic restart. When you run a task through an ECS service, it's different. The service keeps the task running. If it crashes, ECS automatically brings it back. Now, when should you use each one? Running a task manually is great for short-term jobs, batch processing, or quick testing. It's simple, fast, and perfect when you don't need the task to stay alive. Running through an ECS service is better for production applications, websites, or APIs. You need it when your app must stay available at all times. Let's talk about scaling. If you run a task manually, there's no auto-scaling. You have to start tasks yourself. But with ECS Service, you can automatically scale tasks up or down based on the load, using application auto-scaling. Now, what about load balancers? Manual tasks can't attach to a load balancer. With ECS Service, you can easily attach an application load balancer or a network load balancer to distribute traffic evenly. High availability is another key difference. When you run a task manually, there are no guarantees. If it stops, you have to restart it yourself. ECS Service ensures the desired number of tasks are always running, automatically. In simple terms, run a task manually when you want to test something quickly, or when you have a one-time batch job, like a small Java program that finishes after a few seconds. Use an ECS service when you need your application to stay alive, restart automatically if something fails, and scale based on user demand. Now, let's relate this to a few real examples. For a web server like Nginx, you definitely want to use an ECS service. It needs to be available all the time. For a database like MySQL, you would also use a service, but it's a bit tricky. ECS and Fargate aren't ideal for production-grade databases, but the service model is still important. For a simple Java batch job, there's no need for a service. Just run the task manually because the job is short-lived. So here's the key takeaway. If you want your ECS tasks to survive crashes, auto-recover, scale with demand, and serve traffic reliably, always use an ECS service. If you are just experimenting or running short one-time tasks, running a task manually is all you need. To summarize, in this video, we explored Amazon ECS, a fully managed container orchestration service. We covered the key components of ECS, including clusters, task definitions, tasks, and services. We walked through a hands-on setup by creating a cluster, defining a task, running a task, and setting up a service using AWS Fargate. We also discussed the differences between running tasks manually and using a service, highlighting how services provide high availability and automatic scaling. Overall, ECS is a powerful choice for container management, offering simplicity, flexibility, and deep integration with AWS.